Okay, here we solve this problem. This is the problem. I have written a few things. I've written a few things related to this problem. I will explain what it is. First, you look at the problem. You read the problem and find out what data is given. At certain temperature, ethyl acetate is saponificated. That is, ethyl acetate is reacted with sodium hydroxide. That's called ester hydrolysis with base. That's called as saponification. The data at various time in minutes, various time. This is given. Volume is given. Volume of acetic acid, 0.1 in acetic acid, used to titrate 10 ml of unreacted alkali. This is data, and you are asked to show that this data belongs to a second order reaction. Then you have to prove that the data taken is for a second order reaction. And that is the problem. And this is the reaction that ester reacts with sodium hydroxide or potassium hydroxide. That's called saponification. Ester is reacted with alkali, will give you a product, as you know. Okay, that's all. This is I'm conducting this reaction in a reaction vessel. I've taken ester. This is ester. This is very, it's not very clear. Okay, anyway, this is ester reacting with sodium hydroxide. Ester reacting with sodium hydroxide gives product. This reaction is not at started at zero time. I've just mixed ester and the sodium hydroxide. I've just mixed it. When I mix, I should not allow the reaction very instantly. I should withdraw 10 ml of the reaction mixture because this data is taken for withdrawing 10 ml of unreacted 10 ml. That is 10 ml of unreacted alkali. You have to think twice, right? As ester is reacting with sodium hydroxide, the unreacted sodium hydroxide that we analyze here. This is to monitor kinetics, to monitor or to find to study the kinetics of this reaction. I have to monitor either reactant concentration or product concentration. Concentration of product or concentration of reactant I have to monitor. This is convenient. Sodium hydroxide. I can monitor concentration of sodium hydroxide because I can react any acid. By reacting the reaction mixture with any acid, I can monitor the concentration of NaOH in the due course of reaction. It is not easy to monitor the concentration of ethyl acetate because okay, it is not easy. That's all. Then the other molecules also. So it is easy for me to react because it is alkali. I can react with any acids, any primary strand, any acids. That's all. So here I've taken acetic acid and sodium hydroxide. I'm reacting it at zero time. That the reaction is not started at zero time. I'm withdrawing 10 ml. Why? Because the data here is given is for 10 ml. 10 ml of the reaction mixture is taken out of this here in the reaction bottle. The reaction will proceed. I'm not going to disturb the reaction. At various different time, I'm just taking out the reaction mixture. I have to stop the reaction, then titrate with the acetic acid. So here I'm taking out the reaction 10 ml of the reaction mixture at zero time into a conical flask. So I'll stop the reaction at zero time because I want to find out amount of sodium hydroxide at zero time. If I allow the sodium hydroxide to react with the ester, the amount will be decreased. So I should not, at zero time I want to find out the amount of sodium hydroxide. So I should not allow sodium hydroxide to react with acetic acid, ester. So I have to withdraw 10 ml of the reaction mixture. uh, I'll add I will add this mixture 10 ml of the mixture into a conical flask where I'll add ice cubes to stop the reaction, to arrest the reaction at zero time. Zero time, the meaning is the reaction is not started. So I mix it, I'll take out 10 ml of the reaction is taken out. I added ice and I added indicator and reacting with the acetic acid, 0.1 and acetic acid taken in the burette. That's all. And then zero time, I found at zero time the amount volume of acetic acid required is 16 ml. And at the fifth minute, at fifth minute, I'm again withdrawing, taking out 10 ml of the reaction mixture, and I arrest and transferring into a conical flask. I stop the reaction by adding ice cubes and adding indicator and reacting with acetic acid, 0.1 and acetic acid. So the volume required is 10.2. Right. So this is the reaction is going on in the reaction bottle. I'm not disturbing this at constant temperature bath. I'm not disturbing this reaction vessel, and I'm taking out the reaction mixture just to monitor how much of sodium hydroxide is left unreacted at various time. Unreacted sodium hydroxide is the concentration of unreacted sodium hydroxide is monitored at various time. That is zero time, 5th minute, 25th minute, 55 minute, 120th minute. So at the beginning, you would have taken large amount of sodium hydroxide. That is, the concentration will be maybe a certain concentration you would have taken. That initially that would be larger. That is why acetic acid required to react with 10 ml of a reaction mixture will be 16 ml. As the reaction proceeds, then the volume required of acetic acid will be less. This goes on decreasing because here sodium hydroxide goes on decreasing because it is reacting with ester. Okay, that's all. We solved the problem. Then acetic acid is given here. Volume of acetic acid required is given here. See, I'm reacting here. It is 0.1 and acetic acid. 0.1 and acetic acid is reacting with NaOH. That is reaction mixture. 10 ml of NaOH. This 10 ml of NaOH. And then amount of acetic acid required is 16 ml. 16 ml of acetic acid is required. So if you use V1N1 formula, you can find out sodium hydroxide concentration. So this is, if you work out, you will get 0.16. This is sodium hydroxide. The same way you have to find out concentration of NaOH at various time. That is 5th minute, 25th minute, 55th minute. At various time you have to find out concentration of unreacted NaOH from this data. That's all. Then I'll use formula. This is the formula. At the fifth minute, I have to find out K value. K is given by X. X is given by A minus X. A, what is A? Initial concentration. What is initial concentration of NaOH? It is 0.16. 0.16 is initial concentration. Initial concentration minus A minus S. What is A minus X? A minus X is actually concentration of NaOH is various time. Various time is A minus X. So if I subtract, I will get A minus X value. At fifth minute, X value is I have to minus A minus X. So 0.16 minus 0.102. If I subtract, I will get X. So therefore, 0.16 minus 0.102. 0.102. I am subtracting to get X value. Divided by A. A is initial concentration. Initial concentration is 0.16. That is, at zero time, the concentration of NaOH is 0.16. Into what is time T, right? time is fifth minute, and a minus x, at fifth minute, unreacted amount is 1.02, that is a minus x is 1.02. So if you work out you will get 7.1 into 10 power minus 1. Unit for second order rate constant equation is decimeter cube, mole inverse, minutes inverse. So this is at fifth minute, this is rate constant. At the 25th minute, let me k equal to 25th minute, k value equal to at 25th minute x value. Here look at the formula. X value will be a minus x. A is 0.16. At 25th minute, a minus x value is 0.043. Therefore 0.16 minus 0.043 divided by what is that? A is 0.16 into time is 25th minute, and a minus x value at 25th minute is 0.043. If I work it out, this, I will get 6.8023 into 10 power minus 1. So the same unit. And find out at 55th minute the value k is the same way. You have to find out the value of k is 6.7687 into 10 power minus 1. You write the unit. And 1/20th minute k value is 7.0549 into 10 power minus 1 decimeter cube, mole inverse, minutes inverse, right? Okay, then at various time I just found k value. It is here 7.1 10 power minus 1, 6.8 10 power minus 1, 6.7 10 power minus 1, 7.0 10 power minus 1. That is, they are almost same value, almost you get constant value. Therefore you learn that k is a constant value. Therefore I conclude that this data belongs to a second order reaction. I found using this data, I found this saponification reaction follows a second order kinetics because I've got constant value. Because I must get a constant value, k must be a constant value for a given reaction at any time. So therefore I concluded that this reaction follows a second order reaction. Okay, that's all.